Today's lesson's on section 9.5, factoring x squared plus bx plus c. Again, we've started to factor polynomials, and we talked about in the last lesson, 9.4, one way to do that is kind of like reverse distribution. Today we're going to talk about reverse FOIL, reverse table method. Remember back when we did in section 9.2, we learned how to multiply two binomials together, something like x plus 5 and x plus 6. And again, maybe just kind of quickly showing something like FOIL here for this one. So x times x would give me x squared. X times 6 would give me 6x. 5 times x would give me 5x. And 5 times 6 would give me 30. And then we combine the like terms, and I get x squared plus 11x plus 30. Well, lately we've been starting to talk about now. Again, a lot of times in math, we learn how to do something one way. So we learn how to multiply binomials and get some kind of trinomial. And then we also learn how to go the other direction. Now we want to factor. We want to take this trinomial and break it into the factors, the things that multiply together to give me that. In this case, it'd be these two binomials. But I want to be able to see how can we do that. And you want to see the patterns for how that happens. And once you recognize how that happens, we can use that when we start to solve polynomial equations. So I want to look at something like x squared plus 11x plus 30 and know that to start off, we're going to look for the pattern here. How can I see? What can I see in those numbers that would tell me this is the two binomials that would factor to, the two binomials that would multiply together to give me that original trinomial, okay? So first of all, let me go down here and say, so factoring a trinomial, again, is like reverse FOIL or reverse table method. So if you're filling this in along with me, here's what you should be writing. Reverse table method. Again, we talked about one way to factor is like reverse distribution. We'll look for that often in these problems too. But even more often, when we look to factor and actually solve something, we're going to do almost like the reverse of FOIL, the reverse of table method. So it says factor x squared plus 11x plus 30. We'll realize that's that same answer that I had up here, right? So if I'm just going to bring it down here, we already know what the answer to this factor in this trinomial should be. It should be x plus 5 times x plus 6, just like I had above. And what I want you to do, you can pause the video or even just try to spot, okay, right now, how can I see that this trinomial is going to yield these two binomials? What are the patterns? What can I see in each of the terms up here that will tell me that, okay? And when you start to find out, again, and when you start to make the connection here and see how I can make these two binomials, you'll start to see, and this happens all the time as we go on in this chapter, this first term comes from, right? It's like the f in FOIL, so it comes from multiplying these first two terms in the binomials, okay? So it's the product. It's the product of, I guess I'm just going to say the f, because that's like the f in FOIL is what I'm talking about, the first terms, right? It's the product of the f. That's where this comes from. So then when I'm factoring, I can know that, well, I'm going to break this apart, and that's what's going to go in those first two spots, okay? Then, looking at the other end, this 30, and the sign in front of it will be important too, so I'm going to circle that, positive 30. What do you know? If you look at the number, the binomials down here, that comes from these two spots, right? It's the product of the last terms when I talk about FOIL, or the bottom right corner of a table if I want to talk about that. This is the product of the L, the last terms, okay? Now, maybe the toughest one, but as you look at it, I think you'll see, how do you get the middle term, or take this middle term, this middle number, and how do you get it to what we get down here? And what you start to spot is that it's actually the sum of these last terms, like the O and the I, right? Because it comes from the O and the I of FOIL, and when I combine the like terms, so it's the sum of the factors. I'm just going to put the O and the I right now because that is what happens. But what we're going to think is that if we add the factors of this number, the ones that work, we need to get this middle term, whether it's positive, negative. In this case, it's positive 11. We need to be able to get that term. So that's what we're going to look for as we do some of the examples on the next couple slides. And as we do some, you'll get better and better. Let me guide you through some right now. So this first set of examples, let's zoom in here. Again, we're starting to factor now. We multiplied before, and now we are factoring. So we're trying to break this trinomial apart into the binomials that would multiply together to give me that. We're trying to change it into factored form is what we're doing, okay? Well, again, some of the first hints that I can give you, just get this started, is this first term. When you look at that, that tells you what the f in both these first binomials are going to be, the things that multiply together to give me this. And in this first section, they always start you off with x squared. So that means that these first two terms are going to be x and x. Because when I do the f of FOIL, right, x times x would give me x squared. So they start you off nice. In the future, we'll have other things that'll be in front here and it'll be a little trickier. But right now, just to start seeing the patterns, know that that's how a lot of these are going to start today, okay? Look at the last number. Again, it's positive 12, right? So since it's positive 12, again, and the numbers we found will come from here, okay? We need numbers that go here and here that multiply together to give me 12. Now, this will be something that I want you to do all the time as we go on in this section. And I know it seems like for certain numbers it's not too tough, but as the numbers get bigger, it's really helpful. And even when the numbers are smaller, you'll find out it's helpful. Write down the factors next to that number. What are the factors of 12? Because we're going to use one of these combinations. So as we go through problems like this, I'm going to write the factors down, like 1 and 12, 2 and 6, 3 and 4. Like I'm going to write all those factor combinations down, and that'll help me figure out then what numbers got to go here. And then we look at the middle term number, 7x. Well, again, this comes from the sum of the factors that I have over here. And if I look at these factors, 1 and 12, 2 and 6, 3 and 4, 3 and 4, those are the ones that have a sum of 7. So 3 and 4 are probably going to be the factors that I'm going to use down here, okay? Now, because this is positive 12, and I'm trying to add it and get positive 7, I'm going to find out that both my signs are going to be plus, and it's going to be plus 3 and plus 4, okay? Now, if you didn't know, again, or if you weren't sure about your answer, like this is your answer. That's you factoring that trinomial, finding the two binomials that would multiply together to give me that answer, okay? But if you didn't know, you could now do something like table method or FOIL and just double check and make sure that you got it right. So if I multiply x plus 3 and x plus 4, it should give me the original. Otherwise, it wouldn't work. So the top left corner, x times x gives me x squared. Top right corner, I get 3x. Bottom left corner, I get 4x. And 3 times 4 gives me 12. And when I collect the like terms, I get x squared plus 7x plus 12. So yep, it did work because that's what I had up here. This is the answer. That's that polynomial in factored form. That's what I'm trying to get to. Okay, let's keep moving on here. Again, as we do some more, I think we'll start to pick up on it the more of these we do. So I'm going to factor this trinomial now, x squared plus 8x plus 7. I'm going to start off, often one of the first things I do is draw the two sets of parentheses there, because typically that's how it's going to factor. I'm going to get two binomials. This is a trinomial, 3 terms, and I'm going to get two binomials when I'm done. Again, this first term is x squared, so what do you know? That comes from x times x if I was multiplying, so nice enough. I'm just going to have x and x there to start. The last number is positive 7. Well, nice thing about positive 7, if I start listing the factors, there's only 1 and 7. So that's the only numbers that can actually be there. And since it's positive 7, and I'm trying to add together to get positive 8, what's going to happen is then, when I'm thinking about this for a second, when I multiply things together to get positive 7, what does that tell me about the signs in these two binomials? Well, if I'm going to get a positive number, that means that the signs either have to be both negative or both positive. Like they both have to be the same thing if they're supposed to multiply together to give me a positive 7. Since I'm trying to get positive 8, what do you know? Both these signs are going to be plus signs. And the only factors I got, like we said, are 1 and 7. So my answer ends up just being x plus 1 and x plus 7. And that's my two binomials this one would factor to. Okay. Let's take a look at number 3. So I'm going to try to factor this trinomial into two binomials. Again, we start off with x squared here, so it's going to be x and x. I look at that constant at the end, it's 18. Okay, so I need factors of 18, and they're going to have to add together to be 11, because that's the middle term. So let me start off by listing factors of 18. 1 and 18, 2 and 9, 3 and 6. As I look at that combination, those combinations, which ones will add together to be 11? Well, it's got to be 2 and 9 in this case. So x plus 2 and x plus 9 is what that trinomial is going to factor to. And again, I could double check it, but no, that's what we're trying to get to. It almost looks like it's the uncompleted answer, but that's the answer. We're trying to factor it and get to this. And again, we'll find out in the future how that helps us solve these kind of problems. All right, one more. X on this slide. We have a lot more examples here, but one more on this slide. X squared plus 22x plus 72. Well, again, x squared means it's going to start off with x and x. And now again, here's where it especially helps. Big numbers like this, positive 72 at the end. So start listing your factors of 72. And at any point in this video, you can pause it and you can start going ahead of me, because that's what a lot of this is as examples. You go ahead and try some other ones, and then you can see if I get the same thing that you do as I catch up to you. Okay? Okay, factors of 72. I got a lot of factors of 72. So this is one where it really helps out. And I need to get to positive 22, right? So which set of factors is going to do that? It's right here. 4 and 18 actually add together to give me positive 22. So x plus 4 and x plus 18 are my two binomials. Sometimes people ask, can I switch these around? Does it matter? Nope, doesn't matter. You totally can. You could put x plus 18 and then x plus 4, and it's the same thing, of course. Now, this next slide might make it sound like it's going to get trickier, but really all the same rules are going to apply, even when we see subtraction signs. That last slide, you might have noticed there were no really negatives in there, or subtractions. Well, now, if there's subtraction signs, we're still going to think of the same rules, you guys, okay? I want to factor this trinomial into two binomials, the two binomials that would multiply together to give it to me, okay? X squared, they started off with that again. Again, in the future, we'll have other things to deal with, but right now it's x squared, so it's just x and x to start off. And now I want to look at positive 12, okay? I need factors of positive 12, numbers that multiply together to give me positive 12, but they have to add together to give me negative 8. That's something you can already start to think of what's going to happen with my sign then. How my sign's down here, how is that going to work? But let's first at least pick out the factors of 12 before we go any further, okay? 1 and 12, 2 and 6, 3 and 4. So I need factors of 12 that have to give me a negative 8. Well, and we mentioned this just a little bit on one problem last slide. If I have to multiply two numbers together to give me positive 12, but when I add them, they got to give me negative 8, what do you know? These signs are both going to be negative, because the negative times the negative will end up giving me the positive 12 that I need. So this is going to work out, but it's going to be x minus something and x minus something. And then I still want them to sum together, the factors to sum together to give me negative 8. Which set of factors is that? That's got to be 2 and 6. So x minus 2 and x minus 6 is what that one factors to. Okay, so even with negative subtraction signs, still all our same rules apply that you're going to use. Okay, take a look at this next one. I'm going to factor into two binomials. It's x squared to start, so it's going to start off with x and x. The last number here, the constant, is positive 20. So let me just start off by listing factors of 20 before I go any further and start talking about the rest. 1 and 20, 2 and 10, 4 and 5. I need factors of 20, and they got to get to negative 12 when I combine them, right? Notice again, it's positive 20. So I need two numbers to multiply together to give me positive 20. So the signs, that tells me both the signs will be the same thing. And if they add together to give me negative 12, that tells me they both should be subtraction for this one. So x minus and x minus is what I'm going to get. And if they both got to get to 12, I think 2 and 10 is the combination I need. X minus 2 and x minus 10. Okay, zip up to number 7. All right, first one, this one's a little different now than all the rest. Start with my binomials. Again, it does start with x squared again, so x and x when I'm factoring. But now this one, I have to multiply two numbers together to give me negative 18. Guess what? All the same rules still apply, but now I bet you can think of what's going to happen with my signs if I have to multiply two numbers together to give me negative 18. Usually when I'm going through the lesson here, somebody will tell me, oh, well, that means the signs have to be different. Because I'm going to multiply this number, and one's got to be positive and one's got to be negative. So my signs have to reflect that. One sign's positive and one sign's negative. And now when it comes to my factors, let me list my factors still before I go to the next thing I want to say. 1 and 18, 2 and 9, 3 and 6. Oops, 3 and 6, sorry. I need my factors to give me, as it says there, I think it's positive 3, right? Positive 3. So now what I really need is factors that have a difference, because realize one of them is going to be positive, one's going to be negative. So I need factors that have a difference of 3, and I have to arrange it in the binomials to make sure I get positive 3 as the answer. Well, as I look at it, I think 3 and 6 is going to be my combination, and if I arrange it correctly, I need the plus sign to have the 6, because I need that to be positive, and the subtraction sign to have the 3, because then when I combine those, that should give me positive 3, right? Positive 6 and negative 3 gives me positive 3. Let me do this one move just a foil just to show that it is working out, you guys. Oops, I thought I could erase that, but it's not, so I'm just going to go. Okay, let me do FOIL method here. X times x gives me x squared. X times negative 3 gives me negative 3x. 6 times x gives me 6x. And 6 times negative 3 gives me negative 18, like we talked about. And when I combine the like terms, x squared, combining these two gives me positive 3x. And then minus 18. Yep, that's what I needed to get my answer. So that is the correct way to factor it. Okay, let's do that last one. Again, the more we do these, the more you'll start to pick it up. You will start to see and get good at it, I promise. Okay, oops. Okay, here, well, I put both the x's in. Okay, x squared, so I'm going to have x and x. When I look at my number at the end there, it's negative 30. Okay, let me list the factors. 1 and 30, 2 and 15, 3 and 10, 5 and 6. I need factors of negative 30 that'll get me to negative 1, right? That's really a 1 there if I don't write a number in, okay? Well, that tells me since it's negative 30, my sign's going to be positive and negative, right? I need one of each to get me to negative 30 when I multiply them. And I really need factors that have a difference of 1. So 5 and 6 are going to be my factors. And to arrange them so that I get negative 1, I need 5 to have the plus sign in front of it and 6 to have the minus sign in front of it. X plus 5, x minus 6. All right, for this last slide, if you're someone who, as we've gone through some of these problems, are still just kind of fooled on, like, what do I need to do, Mr. Arcade? What'll help me get through these problems? What can I look at every time to help make sure that I factor them correctly? Well, here's kind of my system for factoring these types of trinomials. This might get you through, especially some of these first ones that we're doing, okay? So as there's things here to write down, again, you can pause the video if you need, but most important thing to do, the first thing you'll do when you're trying to factor these now, is you'll look at the sign of the constant. That's a good place to start. And from that'll kind of tell you what the sign should be and what you're looking for in terms of when you're factoring. If that sign is positive, then the two binomials, as it says here, will have the same sign, right? So they'll both be positive or they'll both be negative, because if a positive number comes from multiplying two positives or two negatives, so that makes sense. And then when you're looking for what factors to use, look for factors that have a sum. I have to plug in the name here, or the word. Look for factors that have a sum that will be for the middle term, like they'll add together to equal the middle term, okay? If you look at that constant and it's negative, just like the examples we've done already, so we've done some of these, but now let's just put it in words and something you can write down, then the two binomials will have different signs, right? One will be positive and one will be negative, as we've shown. And then you got to look for factors that have a difference. I'll have to kind of write it diagonal just to squeeze it in here, but look for factors that have a difference of the middle term. Oops. And again, we've done some of these problems too, and I'll show a couple more here at the bottom, but look for factors that have a difference that is the middle term. Okay? So again, if you need it one more time, here's all of it, and then you can pause it and then follow along with my last couple examples here. I'll try to go through them. X squared minus 9x plus 14. Now I'll kind of talk about what we saw up there. So again, we're factoring. We're going to factor two binomials. It starts off with x squared, so I'll start with x and x. And when I look at that last term, it's positive 14. So again, like that was telling us, that means that the two signs will be the same, whatever my two signs are here. And since I got to add them together to get negative 9, well, that means the signs will both be subtraction. And then when I start thinking of factors of 14 that'll work for me, well, again, list them out. Some numbers are easier than others, but 1 and 14, 2 and 7, oh, that's it, 2 and 7. Again, even on some of the ones that don't have as many factors, you will find that's a big help. List out the factors and then try to analyze and figure out which set it should be. Okay, x minus 2, x minus 7 for that first one. All right, this next one. So same idea, I need to factor the two binomials, x squared plus 12x minus 28. Again, it starts off with x squared, so x and x. Again, in the future, this will be something different, but for now, that's how they start us, which is nice, so we can get used to the pattern. The last number is minus 28 for the constant. That tells me that I'm going to have two different signs, one positive, one negative for my binomials. And that tells me when I'm looking at the factors now, again, now I need to find factors that have a difference of that middle number, which in this case is 12. So looking at factors of 28, we'll have 1 and 28, 2 and 14, 4 and 7. And if I look at that combination, I think the factors that have a difference of 12 is right here, is 12 and 14, right? To make sure I get positive 12 like it says up here, I need this one to be x plus 14 and x minus 2. Because 14 minus 2 would give me positive 12. So, yep, that's the combination. That's the factored form, the factors that I need for that binomial. Okay, last two here. I'm going to set my two binomials up. X squared is what I start with, so I'm going to start with x and x. This says negative 8, so that tells me my signs will be opposites, one positive, one negative. 8 only has factors 1 and 8. Oops, not 1 and 18, but 1 and 8, and 2 and 4. And I need factors that have a difference, because again, it's subtraction, like we said. So I need factors that have a difference of negative 7. So I think 1 and 8 have a difference of 7, and then I just got to arrange them to get negative 7. Well, that means that the first one has got to be x plus 1, and then it's got to be x minus 8. Because negative 8 plus 1 will give me negative 7. So that's the combination I need. And the last one, I got my two binomials. X squared, so I got x and x, positive 16 for this one. So my signs are going to be the same, and since they're going to be the same and they're adding a positive 10, that tells me right there they're both going to be pluses. 1 and 16 for my combination, or 2 and 8, or 4 and 4. Oh, looks like 2 and 8 will add together to give me 10. So x plus 2 and x plus 8.